Hi guys, Mr. Lees here doing the higher paper from 2022, paper 2, and we're on question 8, where we have a rectangular plot consists of a rectangular pond there, surrounded by a path. The length and breadth of the plot are x meters, that's it there, by y meters there. The path is 1.5 meters there and there, and it's 1 meter along the side. Okay, so the total area of the pond and path together is 150 square meters. To show that the area of the pond, which is an A area in terms of x, so you'll notice there's no y there, so we need to get rid of the y. Okay, and then we'll determine the maximum area of the pond in a wee while. So show that the area of the pond is given by that equation there. So let's get to work. So the area of the pond and path is just x times y. Let's just check that one out. Area, length times breadth, x times y. Okay. And that we're told that the area of the pond and path, let's get back to that, is 150 square meters. So that means that x times y is 150. That means that y is 150 over x. That will be important in a wee while. It says there, show that the area of the pond. Well, the area of the pond is length there, which is x, take away 3. 1.5 and 1.5. So it's x take away 3 times y take away 2. So the area of the pond is x take 3 times y take 2. And if I multiply that out, I have xy, take away 3y, take away 2x plus 6, multiply that all out. And if you remember, y is 150 over x, so we can now get rid of y by replacing it with 150 over x, wherever we see it. And we have x times 150 over x leaves the 150, minus 3 times 150 is 450 over x, take 2x plus 6. And if we add the 150 and the plus 6, that gives you 156. Take away 2x, take 450 over x. And that's exactly what they wanted earlier on. So that's the area in terms of x. Then for the next bit there, it says calculate the maximum area of the pond. So you probably used these now. You're given a function. We want to get the maximum value of that function. So here we have it there. And the first thing you realise is that I've taken that x and moved it upstairs to be x to the power of minus 1. So the area in terms of x is 156. Take 2x, take 450, x to the minus 1. So the maximum area occurs when a dash x is 0. The differentiation is 0. So differentiate a number, disappears. So we have minus 2 there. And we have minus times a minus is plus 450, x to the minus 2. And I brought it back downstairs because it's easier to solve if you just move it down there. So that has to be set equal to 0. Then we have it there. So I've moved the minus 2 over to give you 2. And x squared can go up there. The 2 can go down there. And we have x squared to be 225. So x has to be the square root of 225, and that gives you 15. Now, does that correspond to a maximum value? Well, let's just test it. So don't forget what the differential was. It's minus 2 plus 450 over x squared. Now you have a calculator. You can check the gradients either side of the 15 that gives 0. If you substitute in 14, you will get a positive number. And I chose 16 there. Substitute in 16, you'll get a negative. That corresponds to a maximum turning point. So x equals 15 does indeed correspond to a maximum turning point. So the maximum area is when x is 15. And what actually is that area? Well, you substitute 15 through the formula for the area. So it's 156. Take away 2 times 15. Take 450 over 15. And that gives you 96 square meters. That's us.